Welcome to the second part of our lecture on interfaces. In this part, we'll deepen our understanding by exploring interface design best practices, how to inherit interfaces, and powerful features introduced in C#8.0+, such as default interface methods. We'll also draw a clear comparison between interfaces and abstract classes, so you know when to use each based on your design goals. Let's begin by reviewing the strategic value of using interfaces in modern software development. So, why should we care about interfaces? First, decoupling. Interfaces reduce tight dependencies between components, making it easier to replace or update parts of a system. Second, testability. Interfaces allow mocking, which is critical for writing unit tests. Third, flexibility. They enable polymorphic behavior across different types. Fourth, extensibility. New implementations can be added without changing existing code. Finally, reusability. Well-designed interfaces support modular, maintainable solutions. Designing good interfaces is both an art and a science. Follow the single responsibility principle. One interface should describe one behavior. Use interface segregation. Don't force classes to implement methods they don't use. Naming matters. Interfaces should be descriptive and start with an I, like IComparable. Stay consistent with your design pattern and keep abstraction clean. Avoid leaking implementation details into interface contracts. Let's quickly summarize. Interfaces define behavior contracts. They allow polymorphism, enabling unrelated types to be treated uniformly. Implementation can be implicit or explicit. Following good design principles leads to cleaner, more reusable interfaces. Keep these principles in mind as we move into deeper territory. Let's reestablish our definition. An interface is a contract, a promise that any implementing type must fulfill. Before C#8.0, interfaces contained only signatures, no implementation. They're non-instantiable and they're designed to enforce consistency across classes. There are two main ways to implement an interface. Implicit, just write public methods that match the interface. This is the common approach. Explicit, you fully qualify the method with the interface name. This hides the method from normal access. It can only be called via the interface reference. Explicit implementation is useful when resolving method name conflicts or when you want to control exposure. Here's a concrete example. Textbox implements iDelete using explicit implementation. You cannot call tb.delete directly. This line would cause a compile time error. Instead, cast tb to iDelete and now you can access delete. This design promotes encapsulation and is ideal when methods are meant to be used through abstractions, not directly from the concrete class. In C#, classes can't inherit from more than one class, but they can implement multiple interfaces. Interfaces can also inherit from other interfaces, forming a hierarchical structure. In the example here, iComboBox inherits from iListBox, which inherits from iControl. A class implementing iComboBox must implement all methods from the entire hierarchy. This enables layered behavior contracts, a powerful design strategy. Starting with C#8.0, interfaces can have default method implementations. Here, iLogger provides a log error method with a default body, calling log. The FileLogger class implements only log and inherits the default behavior for log error. This is a major improvement. It allows adding new members to interfaces without breaking existing implementations. It enhances backward compatibility, especially in large projects and shared libraries, while virtual methods are for base-derived class hierarchies where classes are semantically related. Default interface methods provide a way to evolve interfaces without breaking existing code and are not tied to inheritance, more like a mix-in pattern. Reinforcing our earlier points, always strive for single responsibility per interface, segregated small interfaces. Consistent descriptive naming, clear abstraction, avoid including implementation assumptions. Following these practices makes your interfaces robust, usable, and future-proof. Here's what we've covered so far. Interfaces enforce behavior contracts. They allow polymorphism and multi-interface inheritance. With CR8.0+, interfaces can even define default behavior and always design for clarity and reusability. This slide reiterates key definitions. Interfaces define methods, properties, events, or indexers a type must implement. Prior to C# 8.0, interfaces could not contain fields or method bodies. Interfaces support polymorphism across unrelated types, which is their superpower. Now we shift gears and compare interfaces to abstract classes. Abstract classes provide a shared base structure for derived types. They can include fields, constructors, and implemented methods, but remember, they support only single inheritance, unlike interfaces. Here's a basic example of interface declaration. iWorkable declares a method work. This creates a contract. Any class implementing iWorkable must provide a work method. This is the simplest and most common interface use case. Let's implement iWorkable in a class employee. The class provides the work method as required. This example shows how interfaces enforce behavior, but not structure. We decide how to implement it. Now we combine both worlds. The abstract class animal implements iWorkable, but defers implementation of work to subclasses. This showcases a key OOP concept, abstract inheritance plus interface compliance. Here, two subclasses, dog and cat, implement the work method. Dog.work returns, I watch the house. Cat.work returns, I catch mice. This is a perfect example of polymorphism. Same interface, different behaviors based on object type. Time for a comparison. Interfaces, no fields, no constructors, support multiple inheritance. Abstract classes can have fields, constructors, and implemented methods, but only support single inheritance. Choose based on whether you need behavior plus data, abstract class, or just behavior, interface. Guidelines for choosing. Use interfaces when you want to enforce behavior across unrelated types. Use abstract classes when you want to provide a common foundation with shared code for related classes. Remember, interfaces describe what should be done, abstract classes can describe how it's done. We've now seen the full potential of interfaces, not just as contracts but as tools that support clean architecture, enable polymorphism, and allow safe evolution through default methods in modern C#. We also clarified when to use interfaces versus abstract classes, and how C#'s approach avoids the complexity of multiple inheritance while still providing flexibility. In this final part, we'll shift our focus from theory to practice, looking at how interfaces are used across the .NET ecosystem. You'll discover real-world interfaces that power collections, sorting, data binding, and more.